Good afternoon. Senators Grisanti and Gallivan, thank you for including me in today's proceedings. My name is John Conrad. I am a hydrogeologist and environmental consultant with Conrad Geo-science Corporation, a PBE Scheffler company with offices in Pittsburgh, the Pittsburgh area, and Poughkeepsie, New York. I have some comments to share regarding management of wastewater produced as a result of natural gas production and hydraulic fracturing. First, I'd like to make a few comments to provide a little bit of context and to demonstrate the scale of the challenge that wastewater represents. Natural gas already underpins New York's economy and long-term energy strategy. By next year, the Marcellus Shale will be the largest natural gas play in the U.S., which means now more than ever, in my opinion, natural gas can help New York meet its energy, economic, and environmental challenges. New York now uses more natural gas than 46 other states. Although New York is one of the world's largest consumers of natural gas, we import about 95% of the supply we need from other states and from Canada. And with the Marcellus Shale, we now have the opportunity to meet those needs by extracting the gas beneath our feet. Our reliance on natural gas is likely to continue to grow. The U.S. Energy Information Agency estimates that U.S. consumption of natural gas will increase by 60% over the next 30 years, and reliance on shale gas sources like the Marcellus Shale will triple over the next 15 years, even assuming massive investment in renewable energy sources like wind, solar, and geothermal during that same period. And natural gas is key to the U.S.'s strategy to reduce greenhouse gas emissions. It's a cleaner burning alternative to coal-fired electricity generation. Natural gas is a reliable backup for renewables like wind and solar, which are available only intermittently. And because natural gas is storable and transportable, it can replace oil as a heating fuel and as a motor fuel. About produced water. After a gas well is hydraulically fractured, some of the fracturing fluid returns to the surface with the flow of gas. And as we've been talking about today, we call this produced water or brine. Produced water continues to float to the surface during the life of the well. Because the Marcellus Shale was deposited in a marine environment, it contains large quantities of salt, which leaches into the fracturing fluid, and consequently, produced water contains high concentrations of dissolved solids, such as chloride, and may contain other substances, such as metals and hydrocarbons, that are also present in the shale. A single Marcellus well will use approximately 5 million gallons, perhaps more, of water for hydraulic fracturing, and of that amount, as much as 20,000 to 25,000 barrels might return to the surface during the initial flowback period following hydraulic fracturing. Once it is producing gas, a Marcellus well will generate an additional 1 to 5 barrels of water each day and might generate 5,000 to 15,000 barrels of water over the life of the well. And it's this long-term production of water that represents one of the bigger challenges before us when it comes to shale gas wastewater. Existing environmental regulations in New York prohibit surface discharge of untreated produced water. So as more and more gas wells come online, our ability to process produced water becomes critical. There must be sufficient wastewater management capacity to handle the increasing flow of produced water. So if New York is going to realize the full benefit of its shale gas resources, the development of sufficient treatment capacity must keep pace with natural gas development. This committee has correctly identified waste management as a central issue for unlocking the benefits of New York's shale gas resources. I believe that the demand for water management associated with natural gas production could bring much needed capital investment to New York and lead to a new era of technical innovation. And we've already heard today about some of these innovations that are occurring already in other parts of the Marcellus play. So the good news is that technologies already exist for safely managing produced water. In fact, we already handle much more hazardous waste streams generated at commercial and industrial facilities across this state. Produced water from shale gas does not have the hazardous properties of, say, the concentrated solvent and metals waste from various manufacturing and other industrial processes. The bigger challenge has more to do with the amount of wastewater that will eventually be generated. The problem that needs solving when it comes to shale gas development is a quantity problem, not a technological problem. Assuming that water remains the fracturing fluid of choice, which seems likely, there are numerous options for produced water management. All are discussed in the SGIS. I'll touch on just a couple. before I take questions. Treatment and reuse, we just finished talking about that today. This approach allows gas well operators to simply reuse water produced during the flowback period by diluting it with clean water and using it for fracturing more gas wells. Reuse may entail modest pretreatment to remove suspended solids or adjust pH, etc. Some operators are reporting that they are reusing as much as 80 to 100% of their initial flowback water. Reuse, of course, depends on there being upcoming fracture stimulation treatments needed within a short distance of those wells. Thermal processes are also known to work for these concentrated salt waters. Thermal processes are effective at treating highly saline brine, but this technology is energy intensive and therefore can be costly. It may be possible to set up thermal treatment systems at solid waste disposal facilities equipped with landfill gas power plants. In these cases, heat is used to evaporate or crystallize the brine, and the residue is landfilled or converted to concentrated chloride solutions that can be then used for road de-icing. Crystallization can be used to achieve a zero liquid discharge, where all resulting liquids can be reused or safely discharged. A crystallizer plant might generate distilled water and saleable salt products such as pelletized salt that can be used in water softeners or other applications. At landfills that are already converting landfill gas to energy, it might be possible to use the waste heat from these systems for brine evaporation, an opportunity to use an otherwise wasted resource and increase the cost effectiveness of landfill gas to energy operations. Most produced water from the U.S. oil and gas operations is simply disposed of by returning it to deep geologic formations through injection wells. The federal EPA regulates injection wells through the Underground Injection Control Program, which is part of the Safe Drinking Water Act. Injection wells associated with oil and gas production are designated by EPA as Class II injection wells, and there are approximately 144,000 Class II injection wells in the U.S. that inject more than about 2 billion gallons of brine every day in the U.S. Ohio has approximately 180 Class II injection wells, which today are used to dispose of much of the produced water from Marcellus wells drilled in Pennsylvania. The advantage of deep injection is that it eliminates risks and impacts associated with treating and disposing of waste at the surface. The siting, design, and operation of Class II wells is rigorously controlled by state and federal regulatory agencies, and the disposal zones must be demonstrated to be isolated from freshwater aquifers. For these reasons, disposal by deep injection is considered to be highly protective of shallow underground sources of drinking water. Until now, there has been little demand for Class II injection wells in New York, but it is reasonable to assume that this technology will provide at least part of the wastewater management solution in coming years. And I'll end there and answer any questions that the committee might have.
Thanks, John. Just a couple of questions, John. There was some testimony earlier about these deep injection wells may not be so easily to get at in New York State because of the geology and the rock formations underneath compared to Ohio. Would you agree with that?
It's uncertain. My company is one that is studying the geology of New York and Pennsylvania for the purposes of injection, so it remains to be seen. There are places where it looks promising that there could be at least some injection.
Okay. And I noticed on here too you have reuse is always a good thing if you're going to reuse it. And then I think somebody talked about that earlier, the thermal distillation as far as it being very expensive. Probably extremely expensive. But I appreciate your testimony here today. It'll be put in the record, and I don't know if Senator Gallivan has any questions.
Thank you.
Okay, thank you.